Alrighty, we are looking at a lesson that's going to cover two lessons in Unit 2 here. So we're looking at Lesson 8 and Lesson 9. And we're going to use not only our parts of our book, but we're going to also do a couple of practice problems, take just a couple notes here. But really, the important part of Lesson 8 and Lesson 9 is going to be in this chart, which should be in your cool down packet. So you probably want to have this out as well as your workbook. Lesson 8, we're just going to look at some different parts of what we call end behavior and get some notes and practice this a little bit. So we're going to move through pretty fast to kind of take some of this learning. If you were in class, we would be doing a Desmos. We'd be looking at what we have in common between a bunch of different equations and functions to see what they look like. But this way we'll get there a little bit faster and see what we have. So end behavior, when we define what end behavior even is, end behavior is what is happening at the extreme left side and the extreme right side of the graph. Okay, so what is happening at the extreme left and extreme right side of the graph? Now you're going to see in your workbook, there's lots of different ways that we can also represent this. So if we're talking about everything to the extreme left side of the graph, we're thinking here to the left side, as our x gets smaller and smaller, or as it gets more and more negative, is what I should really be thinking here. So the extreme left, we also talk about it being negative infinity, or as we go farther and farther to the left, as we get more and more negative. Now we say that because we're going to see here in our practice problems that they talk about as x gets larger and larger in either the positive or the negative direction. Okay, so that means as it goes to the left and as it goes to the right. Okay, now when we compare that to something like this, where we're saying as x gets larger and larger in the negative direction, that's what we mean about going to the left side of the graph, whereas larger and larger in the positive direction is going to the right side of the graph. So that's what we're thinking. We're looking at inputs and outputs, okay? So that might be the way that you think about it here, that the extreme left is going farther and farther negative infinity, and the extreme right is as we go farther and farther positive or towards positive infinity. Now our graphs here for polynomials only have two options about what's happening when we go to one side of the graph. We're either going to be going downward forever. We call this down end behavior on the left side, or like this one over here on the left side, it could be going upward forever. Now, there are other kinds of functions that have other kinds of end behavior, things that are going to get closer and closer to a certain value. In fact, we'll see some of those coming up shortly later in this unit. But for right now, our only possibilities are going down and up. Okay, so for all polynomials, we're going to be looking at end behavior. And we want to know what's happening at the extreme left, like this one is going down, this one is going up on the left side. But we're also thinking about what happens at the extreme right side of the graph. Okay, when we look at the extreme right side of the graph, we're looking at something like what's happening over here on this side. So I can see on this right side, this is going up. So we would describe this graph as having down, up, and behavior. Okay, down on the left, up on the right. This one has up, up, and behavior. Both sides of this graph are up. So we would call that up, up, and behavior. We always think what's happening on the left first, and then what's happening on the right. Just like reading, it's like reading from left to right to see what's going on there. So we want to make some general statements so we can see what to expect. And just like we have here, some nice examples of what's going on here, we're gonna see that it's based on two important facts of the equation. It's gonna first of all be based on the degree of the function. So degree is one thing that's going to tell us if the end behaviors are opposite, like these two are, or if they match each other, like these two match. Okay, so let's go to our chart and let's start writing down some of this idea. When we define end behavior, we're talking about where the graph is going. At the extreme left, negative infinity, and the extreme right, positive infinity, sides of the graph. And we're already seeing that it's based on two important things. The first thing that we look at is the degree of the function. The degree of the function, if it's an even number or if it's an odd number, is going to have different kinds of end behavior. Okay, so remember that the degree is the highest exponent. Now, it doesn't always have to be the first one in the equation. So go, like we've been talking before, go looking at all of the exponents, and we're looking for just the highest exponent in the whole thing. Now, this means it does have to be in standard form. So standard form is going to show us this much better, that we can see what's going on. Not factored form, right? So we don't want the stuff in parentheses. That's not going to be helpful. When the degree is an even number, things like x squared, x to the fourth, x to the sixth, any even numbered degree, the ends will match each other. End behaviors match. There's a time where I was saying they were equal end behaviors because they start with E. Even degree, equal end behaviors. Okay, so this is where we're going to see something like this one here. This is an even numbered degree. Our end behaviors match each other. An odd degree, things like x to the third, x to the fifth, even x to the first power, because 1 is an odd number, our end behaviors are going to be opposite. So if our end behaviors are opposites here, that means if one side is going down, the other side is going up. If the right side's going, or the left side's going up, the right side is going down. So even, equal end behaviors, odd, opposite end behaviors. Okay. So let's just do a little Desmos. I've got a Desmos screen up here too. So I already have x squared graphed, and I can change that to any number of different equations. I'm just going to put a whole bunch of them here, and I can see that if I change that number, not there. If I change it to any even numbered exponent, the end behaviors are still matching. They're going up and up, up and up, up and up. Even if I add a bunch of stuff outside of here, like 17x minus, I don't know, 50. I don't even know if I'll be able to see this anymore. I could zoom way out. Oh, there it is. And I can see that that end behavior is going up and up and up. I can even put a number in front of this x squared. I could put 2x squared. I could put 200x squared. I could put 0.5x squared. I can put any number there that I want to, and I'm still seeing this up up end behavior. All right, so let me turn off some of these wacky ones that I have, and let's just go back and look at some of our basics here. So putting some different numbers, even like 0001 out there, ooh, that's a little tough to see. But even this still has this slight curve coming upward here that we can really see that it's still heading in that same way. Now here's the only thing that's going to change it. We can put any number we want out front. But as soon as that number out front, remember that's called the leading coefficient. As soon as that number is negative, did you see what my graph just did? I put a minus sign here and my graph immediately flipped upside down. It immediately went from the happiest graph you've ever seen, the big old smiley face of a graph here, to a real downer, a frowner of a graph because of that negative symbol. So this is where our other part comes in, that we can start to tell end behaviors. And again, all of those ones that I did were even exponents, even degree. So the leading coefficient is going to tell us what is happening on the right side. Okay, so the leading coefficient, remember, is the number in front, the number multiplying the highest degree. So if that number is positive, the leading coefficient is going to tell us what happens on the right side of the graph. Okay, so a positive leading coefficient tells me that the right side is going upward. And then because the two end behaviors match, that means the left side is also going upward. So we could have a graph shape like that. Now there could be any number of wiggles in between there. So I want to also say that too, that we could have any number of wiggles that are going on there, something like this. That still has end behavior that is up on the left and up on the right. So this, no matter what, will have up, end behavior. Some examples of this, we just need to have things that have an even degree and a positive leading coefficient. Things like 12x to the fourth, something as simple as that. 0.2x squared plus 17x minus 3. Pick your favorite number. My favorite number is 8. Raise it up to any even exponent like 100. You could have any other values, even to the 99th power and the 98th power and the 97th power. This is the one that carries all the power, so we are looking for the highest degree and the leading coefficient in front. And the very moment that we turn any of these leading coefficients negative, this is what makes the right side go down. So as soon as we have something like a negative 12x to the fourth, still an even degree, so it still has matching end behaviors. But that negative tells us that the right side is down. Our end behaviors still match because it's even, which means my left side is also down. And again, it can have any amount of wigglies happening. We have down on the left, down on the right. It is down, down, and behavior. So I'm going to write another example here. And remember, it can still be a decimal. But this time I'm going to put it where it's not the very first term. Okay, so if we have something like 4 minus 17x minus 0.2 x to the 8th power. We're going to go looking for that highest degree, and we're going to look for that leading coefficient. So these are the two things that matter right here. There's a negative sign in front of the leading coefficient that tells me down on the right. It's an even degree that tells me the left side's going to match. Okay. So we could write lots of different polynomial functions, different equations that would match it, but we're always thinking even degree, negative leading coefficient, down, down, and behavior. What's cool about this is the leading coefficients tell us exactly the same thing down here for our odd functions. So a positive leading coefficient is still going to tell us that the right side is heading up. So a positive leading coefficient, the graph overall is going to the right side, going upward like this. It's just that the odd exponent, the odd degree, tells us that the behaviors are opposite. So whatever happens, the left side is going to be opposite the right. Okay, so positive tells us what's happening on the right side. It's positive, it's going upward. Okay, so positive generally means we're going up. That's true here. So we have down on the left and up on the right. We have down, up, and behavior. So examples of this might be something like x to the 3rd power, something as simple as that, but we could also put all kinds of other stuff. 20x squared, 4x minus 2. All I'm looking at is the degree and whether this leading coefficient is positive or negative. Okay. So other examples of this might be something like 14x to the 9th power minus 17x to the 7th power plus 98. I'm just kind of making some stuff up here. All I care about is the degree and the leading coefficient, whether it's positive or negative. So our negative leading coefficient still always tells us what's happening on the right side. Because it's negative, it's going to be a real downer of a graph. So overall, it's heading down on the right-hand side. The odd degree tells me that the left side is going to end up going opposite. Could have lots of wiggles in between there, I don't know. But it's going to be up on the left side, down on the right. Okay, so when we talk about describing end behavior, we're going to use these kind of, you have to have a left and a right side because we want to know what's happening on both. So again, this could be any of these equations just with a negative in front. Maybe it's a negative x to the 3rd plus 20x squared minus 4x minus 2. Maybe it's just a negative 17x because that's to the 1st power. That's an odd number. And you may know that that's a straight line with a slope going downward. This also has up on the left, down on the right, and behavior. And any other kind of weird, wacky number, we could do a fraction like negative 1/2 x to the 77th power. Anything else that's happening doesn't matter. We're looking for just the highest degree and the leading coefficient. Okay. So big idea. The leading coefficient tells us what's happening on the right side. Tells us, oops, sorry. The leading coefficient, I'm going to abbreviate that LC. The leading coefficient tells us the right side direction. The degree is going to tell us if the left matches or is opposite. So we have some examples written down. You can certainly go to Desmos and you could graph any equation that you have and you could see if it is a even or odd degree, positive or negative leading coefficient, and see what that graph might look like. Let's go back to our book. We're going to skip section 8.2 and 8.3. Okay. And we're going to try that warm up here for lesson 9. Okay, it's a cover up. So the idea about end behavior is that it's telling us what's happening at the extreme sides of the graph. Everything else we've been working with tells us what's happening in the middle, right? Our constant tells us our y-intercept. Our factors tell us our zeros of the graph. They're all stuff that's happening here in the middle, but it's this end behavior that tells us what's happening to the extreme left and right side of the graph. So they're asking us to match these things that would be here. So I'm going to just take a quick look at this. It's in factored form. If I did a bunch of multiplication here, I would be able to get it to standard form, but I see I have an x that'll multiply an x that will multiply a negative x. Okay, so somewhere in all this multiplication, I'll have an x times an x times a negative x. That would give me a leading term of a negative x to the third power. Okay, if I'm just looking at my x's, in factored form, I'd have to multiply it all together to get it to standard form. Notice that end behavior is easier to spot when we have standard form. We can figure it out from factored form, but we have to do this kind of step first. So I have an odd degree. I have a negative leading coefficient. The negative leading coefficient tells me it's going down on the right. The odd degree tells me it's opposite on the left. So I have something with up, down, end behavior. That matches with C right here. Okay, so I use these little arrows. They help me remember what's going on the right side and then on the left side. Let's check our next one. This one is in standard form, but I have to go hunting and looking for the highest degree term and a positive leading coefficient. That positive leading coefficient tells me it's going up on the right-hand side. The even degree, it's an even number. That means my left side is equal. This is going to match graph A because it's got up on the left and up on the right. And in part 3, I see I'm going to have a little multiplication to do here. I would have 5x plus 15 minus 5x. Now 5x minus 5x gives me nothing. I am just left with 15. These two cancel each other out. This is nothing but a straight line. I don't have a degree at all. I have a straight line at 15. And that's what B is going to look like, a straight line. Now for this one, we don't have a match that goes with D. So I have up on the right, that's going to tell me I have a positive leading coefficient. I have an opposite, it's down on the left. So this would have to be an odd degree. So if I had something like a positive x to the 19th. That would work for this kind of graph. Alrighty. Sorry. So we can use this definitely to start seeing where things will be like this, but really it comes down to the practice problems. Now, if we just did a couple of these, notice that they have it written out in words as x gets larger and larger in either the positive or the negative direction, meaning it doesn't matter if I'm going to the left or to the right. Our function gets larger and larger in the positive direction. So it's saying it's going up on the left and up on the right. I'm going to look at my nifty chart and I see that up end behavior is an even degree and a positive leading coefficient. So I'm looking for things with a positive leading coefficient and an even degree. That would be B, would match that. Even degree, positive leading coefficient. Part A has an odd degree and a negative leading coefficient. Negative leading coefficient is down on the right-hand side. Odd degree is opposite on the left. I need something that is getting, let's see, smaller and smaller as x gets larger and larger. Let's see, as x gets larger and larger in the positive direction, our function gets larger and larger in the negative direction. This is saying it's going down on the right. And as x gets larger and larger in the negative direction, that's going left. Our function is getting larger and larger in the positive direction. This is going up on the left. That is my match there. So 3 would be A would be 3. My next one, I've got an odd degree. Remember, go looking for the highest degree. Odd degree, positive leading coefficient. That's going to match part 2 right here. I know, because it says as x gets larger and larger in the positive direction, meaning as it goes to the right, my function gets more and more positive. It's going to be up on the right. This one is going down on the left. That means we've got a positive leading coefficient and an odd degree. Okay, so some of them get a little bit easier. Let's go check out number 2. It just asks the degree and the end behavior of what's going on here. So first thing I'm going to say is find the degree. The degree is 3. It's the highest exponent. I look for the number in front of that term. It's a -1. So I have an odd degree, a negative leading coefficient. Let's go check out this. Odd degree, negative leading coefficient. My end behavior is up and down. So it's going to be up on the left, down on the right. And we could go to Desmos, we could graph that, and we could make sure that we're right. Alrighty, keep on giving this a try. We can start to see some neat things going on here. We have down, up, end behavior. They're going opposite directions, so I know it has to be an odd degree. B is true. The left side is going, the right side is going upwards, so I have to have a positive leading coefficient. It's moving in a positive direction. And then it asks me about the constant term, whether that constant is positive or negative. Remember that the constant has to deal with the y-intercept. Boom, right there is our y-intercept. This is a +6, so our constant has to be a positive number. Okay. So some more practice, keep on going with that. Hope this was helpful for end behavior lessons 8 and 9.